This honors geometry lesson is on section 6.3, converse of the Pythagorean theorem. The objectives are to state and apply the converse of the Pythagorean theorem and related theorems about obtuse and acute triangles. The converse of the Pythagorean theorem states, if the square of a side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Here is an example. Let's say we are given the following triangle, with one side 3, one side 4, and one side 5. The converse of the Pythagorean theorem says that if we can take 3 squared plus 4 squared and it equals 5 squared, then we can conclude that this triangle is indeed a right triangle. So 9 plus 16 equals 25, and 25 does equal 25. So based on the converse of the Pythagorean theorem, we now know that this is a right triangle. A Pythagorean triple is a set of three integers that we're going to call a, b, and c, for which the following equation is true. A squared plus b squared equals c squared. Listed below are some of the common Pythagorean triples that you're going to see in geometry. You do not need to memorize these, but if you are able to quickly look at the three sides that are one of the Pythagorean triples, then based on the converse of the Pythagorean theorem, you then can conclude that the triangle is a right triangle. Let's take a look at an example. For each problem, let's find x. In example A, we know that this is going to be a rhombus since all four sides are congruent. Therefore, we know that the diagonals are perpendicular to each other. So therefore, we can conclude that these are right angles. So now that we know that this triangle is a right angle, we can use our Pythagorean triples. So if you remember from the previous slide, a 6, 8, 10 triple will give you a right triangle. So x is going to equal 8. So remember, you do not have to memorize the Pythagorean triples. So if you don't memorize them, you can go ahead and set up a squared plus b squared equals c squared. So if we take x squared plus 6 squared and set that equal to 10 squared, and then we solve, we can have x squared plus 36 is equal to 100. And when you subtract 36 from both sides, you're going to get x squared is equal to 64. And then when you square both sides, you're still going to get the same answer of x equals 8. So again, you do not have to memorize the Pythagorean triples, but it just helps a little bit when solving for the triangle. So for example B, we are given three sides, we are given one angle of 28 degrees, and then they want us to find a second angle. The first thing we need to do is we have to see what type of triangle this is. So again, from the previous slide, if you look, you can see that an 8, 15, 17 is a Pythagorean triple, therefore making this a right triangle. Again, if you did not remember that, you can go ahead and prove that it's a right triangle by using your Pythagorean theorem. So 8 squared plus 15 squared should equal 17 squared if this is indeed a right triangle. So 64 plus 225 is equal to 289. So here we can see that 289 does equal 289, therefore we know this is a right triangle. So if we want to find right triangle, we can go ahead and take 90 plus 28, which gives us 118. Okay, so we know that 90 and 28 is 118. So if we take 180 minus 118, we now know that the value of x is going to be 62 degrees. So therefore, x is equal to 62 degrees. For the next example, we're going to work with a trapezoid. We know this is a trapezoid because we have one pair of opposite sides that are parallel. We also have two altitudes drawn that have a length of 60. And then inside makes congruent sides, so 72, and this is going to be 72. And what they want us to do is to find x right here. Okay. All right, so we do know that these are 90 degrees. So again, if you remember your Pythagorean triples, we know that an 11, 60, and 61 triangle is going to make a Pythagorean triple and therefore a right triangle. So we know that both of these are 11. So if we take 11 plus 72 plus 11, we now know that the value of x is going to be 94. Okay. All right. So again, you do not need to memorize the triple. So if you did not know that, you could go ahead and we could call this x, and we could still take x squared plus 60 squared and set that equal to 61 squared. So x squared plus 3,600 is equal to 3,721. So when you subtract 3,600 from both sides, we have x squared is going to be equal to 121. And then the square of 121 also gives us 11. So just two different ways that you can solve for the same problem. For the last example, we're given a rectangle, and we have x as a diagonal. Okay, so again, if you remember that a 5, 12, 13 triangle makes a Pythagorean triple, you can quickly find the value of x. Okay, so as always, if you do not remember your Pythagorean triples, you can go ahead and set up your Pythagorean theorem. So 5 squared plus 12 squared is equal to x squared. 25 plus 144 is equal to x squared. This will give us 169 equal to x squared. So if we square both sides, we're still going to get a value of 13 for x. The last thing we're going to talk about today is acute triangles versus obtuse triangles. So we know in right triangles, if a squared plus b squared equals c squared, it's a right triangle. For an acute triangle, if the square of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. For an obtuse triangle, if the square of the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. So for the last example, we're going to determine whether the lengths given below would make an acute, right, or obtuse triangle, or whether it's a triangle at all, so whether a triangle is even possible. So remember, in order for a triangle to exist, the sum of the two smaller sides must be greater than the sum of the largest side. So for the example, make sure for each one you're checking to see if the two smaller sides, when you add them together, are greater than the longest side. So for the first example, we're first going to check to see if this triangle is possible. So if we take the sum of the two smaller sides, we want it to be greater than the longest side. So here we know that the sum of the two smaller sides is equal to the longest side, therefore not making a triangle. So this is not possible. For the second example, we're again going to test to make sure that this is a triangle that's possible. So if we add the two smaller sides, we can see that the two smaller sides are going to be greater than the longest side. Therefore, we know it's going to be a triangle. Now we can go ahead and test to see whether it's going to be an acute, right, or obtuse triangle. So we are going to take 10 squared plus 14 squared. And I'm going to put a box here because I don't know if it's going to be greater than, less than, or equal to 16 squared So we know that 10 squared is 100, 14 squared is 196, and 16 squared is 256. So we know that 100 plus 196 is 296. So now we can say that 296 is less than 256. So remember, if the longest side squared is smaller, let me change the sign. We said it's going to be smaller. Okay. So remember we said if the longest side squared is smaller than the sum of the two smallest sides, then this is going to make an acute triangle. Right, so for example 3, again we're going to test to see if the two smaller sides added up are greater than the longest side. So root 6 plus root 6 to root 3. Okay, so we're testing to see if it's greater. So root 6 and root 6, so 1 root 6 plus 1 root 6 is 2 root 6. So we do know that 2 root 6 is going to be greater than 2 root 3. So from here we can go ahead and test. So we're going to take root 6 squared plus root 6 squared. And again, we're going to put the box because I don't know if it's greater than, less than, or equal to 2 root 3 squared. Okay, so remember that a square and a square root cancel each other out. So this is going to give me 6 plus 6. And then we're going to distribute. So 2 squared is 4. Root 3 cubed is going to cancel out the root and leave me with 3. So 6 plus 6 is 12. And that is equal to 4 times 3, which is 12. So therefore, this is going to be a right triangle. Okay. And let's go ahead and take a look at our last example. Okay, so for this one, we are going to take 3 plus 5 to make sure that that is greater than 7. Okay, so we do know 8 is greater than 7, so it is going to make a triangle. So now we can test to see what type. 3 squared plus 5 squared. We're going to put our box. 7 squared. So 3 squared is 9. 5 squared is 25. 7 squared is 49. And then 9 plus 25 is 34, so we now know that 34 is less than 49. So since the longest side squared is greater than the two smaller sides squared and added, we now know that this triangle is going to be obtuse. This is the end of lesson on 6.3. If you have any questions, watch the video for a second time. If you still have questions, write down any clarification questions you have, and please bring them to the next class.